Welcome back, guys. So the next question. It is claimed that the expected length of time some computer parts may work before acquiring a robot is 3.5 months. In order to examine this claim, 70 identical parts are set to work. So again, always think about like when you read an exercise or so this, if there's a sample size, take note of that value. So assume that the distribution of the length of time that the, the length of time the part can walk in month is exponential. So now we're talking about an exponential distribution. So yeah, so we have a mean, we have a lambda. So basically from a lambda, we can't find the mean for an exponential. I mean, you can find the standard deviation for an exponential. So we have n here is 17. So what is expected? What is the expectation of the average? So the expectation of the average is just going to be 3.5 because exponential for a single measurement, we already know is 3.5 months that they take before they start a call or anything like that robot. Now the standard deviation, the same story as before. We find the standard deviation for the exponential first, which is 1 over lambda squared. So basically 1 over 3.5 squared. Now, because we are trying to find the standard deviation for the average, not just the single random variable. So basically what we are trying to find is trying to find the standard deviation for the average of the number of time, of the length of time computer get a boot, basically. That means computer will work before they get a boot. So that's basically what we try to find. And so basically we find the average first for a single random variable, which is 1 over lambda squared, because we know the length of time is for one of the random variable basically. So just the length of time before you get a both, we know it's 3.5. But now if we take several sample or several round of the random variable, like we take 70 computer, basically 70 of the random variable in a sense, to make a sample or a sample of 70 of the random variable, the standard deviation of that average is now going to be the standard deviation of the exponential divided by 70. So 1 over lambda square, then divided over square root of 70, basically. So that's basically what you find here. So again, the formula, so it's the same formula that you have here in the book. So yeah, the variance is variance over n. So the standard deviation is going to be square root of that, square root of the variance over square root of n. So, and you see the expectation of the mean of the sample is going to be the same expectation as the one from the original one. Okay. Now, the central region that contains 90% of distribution of the average is the form E of x plus or minus c. So again, see here the central region that contains 90%. So whenever we mention the central regions, always picture this. Now we're talking about this. So if it's 90%, we know that we need to find the Q of 0.05 or Q of 0.95. And so we need to find what C is. So in general, the central region that contains this is in this form, mu plus or minus the Q norm. So again, here we're going to use the Q norm of the upper bound, 0.95 times sigma. So again, this is a formula to remember. And then mu, we know what mu is, we know what sigma is, and we know what Q norm of 0.95 is. Q norm of 0.95 is given by this. And the only thing that maybe here was a bit off was the fact that he did not really make mention of the mean and the standard deviation. Usually this is needed in the just check that. So yeah. So we have, so basically when you find the Q norm, you're going to multiply that by the standard deviation, and you will be getting the value for C. So here they are basically assuming that it's going to be 0 and 1, but let me just check something. So we know what the mean is 3.5. And the standard deviation is given by this. Let me check something quickly here. 5. Okay, so again here is because we are referring back to the z value. So basically we try to imagine a case where we have a mean of 0 and a standard deviation of 1. So yeah, because it's going to follow a standard normal distribution with a mean of 0 of standard deviation of 1. So that's why when we use a Q norm, it's just going to be the Q norm of 0 for 0.95, because the mean of that average here, I mean the theoretical, that's basically the theoretical quantile in a sense. And yeah, so that's how you find C. And let's see here, the next question, the last question. What is the probability the average is more than 4 months? So to find the probability the average is more than 4 months, you need to first of all find the probability less than 4 months. So the probability less than 4 months is less than 4 months is found using P norm for 3.5 and then the standard deviation. But now because we know the total probability should be 1, so we just subtract less than 4 months from 1, and then we get what we get left is a probability that the average is more than 4 months before they say that the computer is going to work before they say we're both. So yeah, that's pretty much the quiz. Just going to see if I didn't miss anything. So again, it's very important to make sure you understand this last quiz. As I mentioned, I'm going to mention the forum. Your next graded quiz, Unit 8, is going to be built on this really identical. So make sure you understand this. So if you pretty much are comfortable with this self quiz, you will not really have any issue with the grade quiz 8. So I'm going to be working on providing some example from previous self quiz that will reflect mirror what you expect to know for the final exams, because I know there's a lot of materials that will cover in this course, and I think it's going to be very helpful if we can narrow a little bit if we can narrow what you need to learn in a sense to better prepare for the exams. So again, it's a lot of materials, and wish you all the best as we enter this final week, and I hope you guys post a lot of questions, any difficulty you have, and things like that. Good luck, guys. Thanks.